Welcome to the Test Guild Automation Podcast, where we all get together to learn more about automation and software testing, with your host, Joe Colantonio.
Hey, it's Joe, and welcome to another episode of the Test Guild Automation Podcast. And today we'll be talking with Grigori all about virtualization and testing, and probably all other topics. Grigori is a solution architect at Parasoft, which provides consulting services for Parasoft's testing solutions to software companies. So he's probably dealt with a lot of companies, a lot of testing situations. So I think you can get a lot of value from this conversation. He's also a speaker at testing and software development conferences on topics like service virtualization and deployment of disposable environments in the cloud, which I think is another hot topic we'll probably touch upon. And so he does a lot of enterprise engagements along the way. So I think you want to listen all the way to the end to get the most out of this episode. You don't want to miss it. Check it out. The Test Guild Automation Podcast is sponsored by the fantastic folks at Sauce Labs, the cloud-based test platform that helps ensure you can develop with confidence at every step, from code to deployment, for every framework, browser, OS, mobile device, and API. Get a free trial. Visit testguild.com/Sauce Labs and click on the exclusive sponsors section to try it for free today. Check it out. Hey, Grigori, welcome to the Guild.
Hey, Joe, thanks for having me.
Good to have you. I guess before we get into it, though, is there anything I missed in your bio that you want the Guild to know more about?
No, I don't think so. I mean, this is probably biggest my biggest exposure since like sixth grade science project. So
Great.
Not much has changed since then. So
awesome. Yeah, good. Hopefully it'd be a better presentation than a sixth grade project, but we'll see.
Mine was pretty great.
Right, mine was awful. It was the volcano with the clay that people always did in the 70s.
Oh, you did that one, huh?
Yeah. Cool. All right. So I guess before we actually dive deep into this, I thought the first topic we'd get into is service virtualization. But I guess how would you describe what is service virtualization before we actually go into what you can do with it?
Great question. So service virtualization is kind of probably an extension of what traditionally is referred to as stubs and mocks and spies and things like that, right? So if we're looking at testing in code, if we're looking at unit testing or maybe some more end-to-end type test scenarios in code, we're looking at things like mocks, and we're looking at things like stubs to help us with our test environments. When we extend out beyond that, when we look at larger systems or distributed systems, we start to see that we need more than just in-code solutions, right? We need more than just a mock or a stub or something like that, right? We need to actually build out services that behave more or less like real services, and that's where service virtualization comes in. It enables organizations to define and develop complex services and complex service behavior to stub out various components within a system to enable test automation, to enable development work, sandboxing, etc. And we're actually also seeing the application extend out to operations side of the enterprise as well. So for sales organizations, right, they need environments for demoing. Typically they don't want to use production environments for things like that, or for onboarding new employees. Let's say you're a bank and you're hiring tell agents and things like that. You're not going to want to expose them to real data. You're not going to want to expose them to real records for them to do training. So anything that you can do to simulate various components or simulate data or simulate services within your system, you can leverage service virtualization for, and that's kind of becoming a really hot topic right now, and it's been for some time.
Yeah, absolutely. So is it a more advanced stubbing and mocking technique?
Yeah, so when you look at stubs, you look at mocks, a lot of times they're kind of defined as some dummy piece of code that either lets you run a test, but you don't care what happens to it, or maybe you do validate on whether or not it's being called correctly. Service virtualization, you're kind of moving outside the code. Now you can leverage service virtualization in your code. However, that's not probably as lightweight as something like, I don't know, a power, a Makito or something like that, right? Or or a power mock, you're looking at specifically service, right? Let's say you have an application that validates a VIN number or something like that, and in your test system, you can't always just keep calling that same service. You can't always call that whatever external service to validate your VIN number. You may or may not want to just virtualize that API call so that you always get a consistent response, a valid, confirming that this is in fact a valid number. At the end of the day, your test probably doesn't care whether it is or it isn't. They just care about the overall end-to-end flow. So in that instance, you could leverage service virtualization rather than putting all that validation logic in code.
Gotcha. So if your application relied on a lot of third-party services that you probably have to pay for as well, does service virtualization help you stub that out as well?
Yeah. So in general, service virtualization, we call these the ABCDs of service virtualization. There's kind of 4 primary obstacles that service virtualization aims to resolve. It's availability, or accessibility, but availability is probably a better term. You in your enterprise, you may have teams that work on a different schedule that are developing services. Services just may not be available. They just might be brittle in that particular environment due to whatever deployment constraints. There's behavioral constraints. So that's the B. We got A, we got B. That's when you're looking for a specific behavior from a particular service. Could be a third-party service, could be, again, an internal service, but in the context of a test environment, you just can't get it in the right state. And so service virtualization can aid with that. Cost is a big one with third-party components, because let's say you're integrating with some third-party component. They charge you, I don't know, 2 cents a hit, or less than 0.2 cents a hit or something like that. And then all of a sudden you have to do performance testing in that environment. That cost is going to scale exponentially, right? So that's a prohibitive. It's prohibitive in the context of performance testing or any kind of testing if you're being charged per hit like that. And then finally, there's data. So just having access to non-production data, having access to test data that is reusable, that you can redeploy on demand, is another constraint for test automation. So service virtualization can address all 4 of those, whether you're standing up at endpoint just because you don't have one, or because you need a certain state, or you need data, or you just want to reduce costs due to integrations with third-party systems or third-party applications.
Nice. So I used to hear a lot about service virtualization and not so much. Have technologies like containerization replaced some of the methods you may have used service virtualization for? Or are they completely different for different needs?
Well, so containerization, I think, if anything, has become an enabler for service virtualization, because one of the blockers, I think, for organizations in deploying service virtualization is, unlike mocks, unlike stubs, they see it as like this big thing you have to set up, right? You have to provision hardware, you have to provision infrastructure, you have to set up some application container or something like that to host your virtual services. And then once we really got into Docker, OpenShift, whatever else, right, that we have for containerization, that's really kind of enabled organizations to say, well, okay, we can just deploy and destroy these things. We can just deploy a container with virtual services, and then we can destroy it after the pipeline has finished executing. And so, if anything, I would say it's been an enabler. I don't think containerization replaces service virtualization, because you still need to build out those services. You still need to build that logic into whatever component you're virtualizing. And there's still a prohibitive cost in using the real systems rather than some virtual asset.
Nice. So there's a big push to shift left that's been going on for years now. So with service virtualization, can you actually use it when you're maybe in the early stages of development and you're just creating more realistic things that when you're creating code to verify it's going to eventually work once you do get everything in place with the third party before you go into production?
Absolutely, absolutely, and service virtualization is a big component of shift left, because when you think about shift left, you're thinking about the ability to run your high level tests, right? Your high level test automation as early as possible and as frequently as possible. And typically those high level tests, right, like UI tests, end-to-end tests, anything that's kind of at the top of that test pyramid, that's usually the most expensive type of test to run, right? The most expensive type of test to develop, the most expensive type of test to run. service virtualization basically says you can run these tests whenever you want, right? You don't have to wait for a specific moment. You don't have to wait for a sprint to finish, and to have all the components within your system available in order to run these high-level tests. So just by being able to provision virtual services, by being able to provision virtual components, and by the way, we're not just talking about HTTP services, right? We're talking about TCP services, FTP services, some custom protocol that some payment processing company uses that maybe not everybody actually has documentation for. Any of those services can be virtualized and deployed as early as you like in your SDLC. So
great. So I guess another trend I've been hearing more about is resilience testing and chaos engineering. So can you use service virtualizations to kind of do experiments with, okay, the service is down, or the service is giving me a funky request back that I didn't expect, to see how your code or system behaves to that?
Absolutely, yeah. That's a pretty common use case, right? Negative behavior virtualization, failure virtualization, and one of the benefits of service virtualization is that teams who develop virtual services can give control to various other parts of the organization in terms of how these virtual services behave. For example, traditionally, if we want to make a change to an application under test, or we want to make a change to some component within our system under test, we typically have to work with a team of developers. We have to work with some infrastructure folks to get the right state, to get the right behavior out of it. All of a sudden, the test team now has control of the virtual service. So if they want to validate that their application behaves, as expected due to failures or exceptions or lack of data, or not being able to process some data, right? Any of those failure conditions that you might want to simulate, all of a sudden they have control of basically switching on that behavior, not having to really redeploy anything, because service virtualization kind of accounts for that and make sure that these changes are quick and can be deployed quickly. So yeah, absolutely, chaos engineering, any kind of failure virtualization and simulation is a good use case for service virtualization.
Great. Now, this was probably a bad practice. I worked at a company that had like 7 sprint teams, but they all worked on different slices of the application. There was dependencies on them. So at the end of each sprint, team would go, I wasn't able to finish it because team Z didn't have their code ready. So it seems almost like if you were doing that type of development, service virtualization could save the day, because you don't have to worry about that team. You can actually maybe mock it up with a service virtualization type setup and be able to test and be on your way.
Yeah, absolutely. So, I think at the end of the day, obviously, you want some cooperation. You want Team Z, Team B, Team A, right? You want everybody working together at the end of the day. You still have your production environment.
Yep,
right. We wouldn't recommend deploying service virtualization in a production environment, for example, right? That's it's more for testing. It's more for development. It's more, again, there's certain operational use cases as well that you can leverage. But from a testing perspective, from a development perspective, one of the use cases that I think we're actually seeing a lot right now is specifically developer sandboxes, and being able to sandbox a whole cluster really of services and logical behaviors from within a system in a single sandbox that can be quickly replicated, that can be redeployed in various corners of your organization, right? Again, leveraging things like containerization and so on and so forth. So for your organization, that probably would have been a good time. When was this, by the way? Was this a while back, or?
Yeah, maybe a while back, maybe not that long ago, 4 or 5 years ago. Like, really dysfunctional team. I had a motto: if you're gonna do something bad, do something bad good. So just trying to find ways to test an insanity almost.
Yeah, well, service virtualization, we've had service virtualization for, actually kind of interesting, we've had service virtualization for probably like 15 years or something like that. And we initially had it built into our SOA testing solutions. So yeah, and back then I think they were even called just stubs or something like that. And it was built into the tool, and then all of a sudden kind of saw the value of, wow, this could really be a standalone thing. Like, it doesn't really matter whether you're using SOA, our SOA solution, or using, some other test harness or or some other way to validate your APIs or your services, you still may want to use service virtualization, right? And so that's when we kind of pulled things out and found that to be a good standalone value.
Nice. So are there any other use cases you've seen? Obviously, you've worked for a company that has a solution, and you must see all kinds of things in the wild. Don't know if there's any other things that you think you could use service virtualization for that people don't even realize how useful it could be for, method X or something.
Well, I think when you start looking at service virtualization, you typically start looking at complex end-to-end flows. That's when you're really finding that you need something more broad in terms of in terms of your test environment, something more stable, and you need to cover multiple components. So when I think about use cases like that, one use case that is probably one of my favorite use cases is for a internet service provider. They have technicians, right? Whenever you get a new modem or you sign up for internet, somebody comes out, somebody installs the modem, somebody acknowledges that, hey, here's your modem, you can sign right here, activates it, blah blah blah. That whole workflow takes about 30 minutes. They give you an hour of 9 a.m. to 9 p.m. to do it, right? And then and then come over and do it. So on their side, on the internet service provider side, they obviously develop the app that these technicians use, right? And they develop the app, and in order to test that app or to do performance testing for that app, they need to be able to simulate 30,000, 100,000 technicians being able to log into that app, going to an address, installing a modem, syncing up with some system somewhere that validates the modem, activate it, then work with the customer account, enable the customer account, and then confirm through the customer account that that all of that works, that you have internet as expected. And then as a user, the technician themselves also have to sign out of that app, right? So if you think about all of the different services that this mobile app interacts with and also relies on actual human interaction in order to complete that end-to-end flow, there's a lot of stuff going on, right? So using service virtualization, they were able to simulate the technician, they were able to simulate the user, they were able to simulate the modem, they were able to simulate the warehouse that activates the modem, or whatever endpoint there that does the thing that it needs to do with that modem, and then they were able to create 30,000 accounts or 40,000 accounts or something like that, just because it's virtual data, right? So they don't have to rely on real geographical locations, they don't have to rely on real technicians or anything like that. And that obviously cut the costs down for their performance testing tremendously and enabled them to do it really anytime.
So how well does someone need to know their application in order to create, a realistic service virtualization? I guess my question is, can you create like a bad service virtualization thinking you're testing something, but you didn't understand your infrastructure enough that your model of what you were trying to virtualize was wrong? Can you like have a sniffer on the interaction you're doing in the wild, and then the service virtualization can kind of mimic that? How does it all work, I guess?
That's a great question. So, short answer, can you create a bad virtual service? Yes. You can do anything poorly. With service virtualization, not just our solution, but all solutions typically will have some convention or some capability to capture traffic, capture behavior, capture interactions between your application under test and its dependencies. This approach has a number of benefits. Among those benefits is that you collect data and you collect behavior, right? So when you have request response pairs, when you have APIs, you have services interacting with each other, they could be making calls back and forth, in some kind of order, or there's a specific sequence operations that needs to occur in order for that flow to be valid. Now we have definition files, we have Swagger, OpenAPI, documentation, right, that can tell us how these APIs are supposed to interact with each other. But then in practice, that's not always the case. In practice, there might be some unique thing, maybe some undocumented resource or something like that gets called, and you might not be able to catch that, right? So when you're developing your virtual services without having that insight, you might miss out on some of those things. But to that point, though, I also say that you always have to go back to your test requirements. traditionally service virtualization is a tool for enabling test automation. So if your virtual services check that box, if your pipelines run successfully, if you're able to do your test automation with the data that you have, you don't necessarily need to build out the most realistic representation of that virtual service. Sometimes you just need a 200 status code back or something like that, along with some status message, or maybe you're returning an error condition, so like a 403 with a specific message in the JSON. So you have to go back to your test requirements. You have to see what you really need from a virtual service, and then make your life easier.
Great. So you mentioned this was really created to help support automation testing. So if you're running a continuous integration environment, CI/CD, do the environments need to be stood up or automatically, or do you have things in the pipeline before the test runs that it knows to start up service virtualization wise, 1, 2, and 3?
Well, a service virtualization solution should be flexible. It should enable you to do test automation that is reflective of, frankly, the maturity of your test automation practice, right? So there's teams, and a lot of teams right now, I mean, you see teams kind of having makeup of, 7 developers, 2 DevOps folks, and, a quality engineer, right? So each team is going to end up having somewhat different pipelines, somewhat different test automation practices a lot of times. Bigger enterprises probably will have sort of a convention on how to do that, but even, with large enterprises, we see kind of different teams doing different things. So the more mature the practice, I think the more you're going to do in terms of dynamic deployments, right? You're going to see more on-demand Docker containers that just will stand up an environment, reconfigure the environment right there and then, and execute tests. For performance testing, a lot of times we do performance testing where we see organizations do performance testing sort of in a manual way, right, where there's a specific block of time that they have and they have to just run their performance tests. Then that's their opportunity to do it, and they have to do it there and then. In that sense, there's probably a more concrete infrastructure in place, right, to remove some of the dependencies on network hops and things like that, or just not have to rely on these kind of dynamic flows. You just want the thing to be there. You want realistic response times, and you want to make sure it doesn't go down for any reason. So, long answer, it depends, right? But from a technology standpoint, it needs to be flexible. It needs to be able to support all those flows. It needs to support simple tests as well as more complex tests that require a stable environment.
Great. So speaking about environments, continuous testing, I think there's another feature, another solution you have, Parasoft's continuous testing platform. Does service virtualization play with that at all, or do they work hand in hand? What's that solution all about?
So, when you think about service virtualization and kind of some of the topics we discussed, right? Dynamic deployments, having infrastructure that's hosting service virtualization. Generally speaking, you need something to orchestrate these things. You need something to be able to look at the health of your virtual services. You need to be able to expose the ability to interact with these services or consume some of these services or even copy some of these services to the rest of the organization, right? There's some sort of governance model usually that comes in with enabling enterprises to leverage service virtualization. So the continuous testing platform is really a way for organizations or for teams to expose that to the rest of the organization or some center of excellence to maintain production grade virtual services. And we say production grade, we mean basically the virtual services that are good enough for test environments or so on and so forth. And the continuous testing platform does that for you, along with other administrative things, right? Or monitoring capabilities, right? If you're doing performance testing, you then maybe want to export that out and kind of show the rest of the team, okay, we're getting these types of response times here. This is what we're getting from the server. This is what we're getting from the application, so on and so forth. So it's that extra layer for enabling DevOps and continuous testing.
So you mentioned performance testing at least 3 times so far, and I've seen a rise in non-functional testing that sprint teams have to deal with, one of them being performance testing. Have you seen an uptick in people that are really focused on performance now?
Yeah, absolutely. Although, maybe for us, we've always kind of worked with a lot of performance testing use cases. Going back to sort of monolithic applications and legacy applications, again, performance testing used to be kind of this thing that you would prepare for, right? It's like it's like Christmas dinner, or Thanksgiving dinner, right? You have to go, get all the things that you need, you have to set up, and then the day of you have to execute. And so performance testing traditionally was always like that, and so service virtualization was a big use case for that, to kind of prepare everything, get everything in the right state. But what we're seeing today is organizations really embracing performance test automation, where they're not necessarily running, tests that will break your application every single time as a part of their continuous pipeline, but they'll run tests to validate that all the SLAs are met, at maybe lower concurrencies, or look for degradation over time, right? If you're running these tests nightly, or you're running your tests, once code is checked in, right? Sort of true CI/CD. You're always looking for degradation. You're looking for over time, making sure that the changes that you're introducing to your application do not introduce unnecessary delays. So we're seeing a lot more of that, and obviously we're also seeing a lot more performance testing from a perspective of user experience validation, right? So we would always traditionally see organizations kind of focus on the services, on the service layer, on the middle layer, on the back-end systems, making sure that they can handle large loads and large concurrencies. But the big focus now is, of course, on the user experience, on making sure that the user page loads quickly, that the images load as expected in the right order, and things like that.
Absolutely. We also touched on data a little bit. Service virtualization, can it help you generate data for you? Because I know that's something a lot of teams struggle with, is actually having the data they need for all their automated tests.
Absolutely. I would say, you kind of have to draw the line between sort of your big test data management solutions and enabling organizations to control their own test data, right? And I think service virtualization is more on that latter side, right? Where when you have virtual services and you have test tools, all of a sudden you can now create some middle ground, right, of that test data. And your virtual services, they don't need real data. They don't need production data. They don't need they don't need to be able to work with other systems, right? When we think about this data too, like the big thing is data needs to be tied together for various services, right? You might have a service that's an account service, right? And that account service has some account ID, and then this account has some bank account, right? That has a bank account ID, and then when you do a transaction, it has a transaction ID, and all these data sets, they're all tied together somehow. And not only that, they're also complex, right? They're not just flat data sets where you have a key and a value. You have a key, an object, a list. Inside the list, you have other objects, you have other lists, and so on and so on and so forth. I mean, you think about an insurance company or something like that. You look at an insurance policy. How complex is an insurance policy, right? And all the different ways that you can have that insurance policy. So now, all of a sudden, virtual services say, well, we're virtual, right? So we can simulate all of that, and we have capability to generate that on the fly, with rules or without rules, basically whatever the test team needs or whatever the stakeholders need, they can just give us the template for the format of data that they need, and we can generate it using virtual services.
So I used to work, once again, for a big insurance company back in the day, and I used to have to create automated scripts just to get the policy in such a point where a manual person go in and rate it against all the different things from Rhode Island or Mass and all the different rules that were into play.
Man.
This sounds perfect. That would have been perfect to use. It sounds like that scenario, because that was crazy.
Yeah.
Cool. All right, Grigori, is there anything else about service virtualization, especially Parasoft? I guess folks that don't know, you do work for Parasoft. Parasoft has a service virtualization solution. When someone's looking for a solution for service virtualization, what should they look for? Does Parasoft have any secret sauce around this that you think kind of would lend itself better to certain organizations than others, or anything like that?
I think generally speaking, when you're working with with vendors, or you're bringing in a technology into your organization, you're always kind of looking at a gradient of solutions. On one end, you have open source. On the other end, you have the big vendor, right? And there's obviously benefits and sort of negatives about each side of that gradient, right? On the open source side, it's free. There's a community that supports it. It's probably fairly easy to deploy, or maybe developer friendly, right? Which is great. But now all of a sudden you bring that into your enterprise, and who's maintaining it? Who owns it, right? Who's going to make sure that bugs are fixed, right? I mean, you're just going to go to GitHub every time and make a commit something. You're going to fix it yourself, right? So organizations do need some sort of vendor support, and not only that, there also needs to be a focus and an interest, I think, from the vendor side to stay on top of that technology, right, and not abandon that technology. On the other side of that gradient is you have too large of a vendor, right? And that's when you're looking at costs that become prohibitive, right? You think, okay, well, we're removing the costs associated with hitting these third-party dependencies, but this is costing us a lot of money. And if we want to increase our concurrency, we have to now pay even more money. And all of a sudden, we're in the same situation that we were before. So I think Parasoft is unique in that sense that we're a privately held organization, right? We don't have a board of directors or anything like that will tell us how to develop our technology. Our customers are our partners. Our roadmap is tailored against our customers and their requirements. So we have a very good sense of what the industry needs, and at the same time you still get that vendor support, that 24/7 support, or chat, or so on and so forth. So if something comes up or log4j happens, right, you have an organization that will fix that and address that immediately.
Absolutely. Okay, Grigori, before we go, is there one piece of actionable advice you can give to someone to help them with their service virtualization, automation, testing efforts? And what's the best way to find, contact you, or learn more about Parasoft?
Absolutely. So Parasoft.com is your one-stop shop for everything Parasoft, but specifically, I think what you might be interested in, if you found what you hear on this podcast interesting, is the community edition. So Parasoft does offer a free version of Virtualize. It's called the community edition. It's extremely powerful, I would say, in terms of being able to develop services and being able to develop frankly pretty complex services just by using the free edition. So head out to Parasoft.com, check out the community edition, check out our white papers, check out our testimonials from customers who've deployed service virtualization and have gotten a lot of value from it. And I think there, Parasoft.com, you can request a demo, you can request us to contact you and talk about your specific use cases.
Thanks again for your automation awesomeness. The links to everything of value we covered in this episode, head on over to testguild.com/A394. And while you're there, make sure to click on the Try for Free Today link under the exclusive sponsor section to learn all about Sauce Labs' awesome products and services. And if the show has helped you in any way, why not rate it and review it in iTunes? Reviews really help in the rankings of the show, and I read each and every one of them. So that's it for this episode of the Test Guild Automation Podcast. I'm Joe, and my mission is to help you succeed with creating end-to-end, full-stack automation awesomeness. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Guild Automation Podcast. Head on over to testguild.com for full show notes, amazing blog articles, and online testing conferences. Don't forget to subscribe to the Guild to continue your testing journey.